Okay, so what we're going to do is we are going to look at applications of the normal distribution. These would be the word problems that are at the end of your worksheet. And so we have this problem right here. The average speed of a car is 65 kilometers per hour with a standard deviation of 4. Find the probability that the speed is less than 60 kilometers per hour. So I'm going to preface real quick that this is normally distributed, as are all of the problems that I'm going to look at with you on this video. You need that in order to use your z-score table. Okay, so the first thing we're going to do is we are going to, overall we need to find what is the probability that x is less than 60. And if we were to draw a picture of that, our mean is 65 and 60 would be to the left of that, and we want this probability. We cannot use the empirical rule or the 68, 95, 99.7 rule because this is not a full integer value of standard deviations away. So we have the probability that x is less than 60. What we need to do from there is we need to change that to a z, because our z-score table is set up with z's. So we need to change that to a z. So we're going to use our formula. Z equals x minus mu divided by sigma, which is going to be x is our 60 minus our mean. Our mean is 65 divided by our standard deviation, which is listed as 4. 60 minus 65 is 5. When I divide that by 4, I get 1.25. Because your table, your z-score table is always set up as 2 digits, you need to always round to 2 decimal places. So now we are answering the question, what is the probability that z is less than 1.25? Since this is area to the left, we are just going to look it up. So if you go to your z-score table and you find 1.25, you're going to see that the probability is 0.8944. In the context of this problem, it means the probability that the speed is less than 60 kilometers per hour, would be 89.44%. In this one, we're going to look at a different problem. This one says is the mean of a given data of a random variable is 81.1 and the standard deviation is 4.7. Find the probability of getting a value more than 83. So again, we are going to assume that this is normally distributed, and it's important that the item is selected at random, as it should have been in the last problem as well. So what we're going to do is we are going to getting more than 83. So we have the probability that x is greater than 83. And so again, if we had a picture of this distribution, our mean would be right here, and that is 81.1. And we want more than 83, so it's somewhere to the right, and it's area to the right. So one more time, we need to set this up with a z instead. So we're going to calculate our z. X minus mu divided by sigma. X is going to have a value of 83 for us. Take away our mean of 81.1, divide by our standard deviation of 4.7. So z is going to equal and this value has to be rounded 0.40. So now we are asking ourselves, what is the probability that z is greater than 0.4? So this is area to the right. Area to the right, we can look up area to the left of negative 0.4. And so if you go to your z-score table and you look up negative 0.4, you find 0.3446. Or the probability of getting a value more than 83 is 34.46%. And in our final example, we've got test scores in a statistics class. Again, we're going to assume they're normally distributed and a value is selected at random. They've got a average score, a mean of 85. And we want the choosing a value between 75. Oh, we're going to change this problem actually. We'll say 70. We're going to change this problem because we don't want to have to be able to use the empirical rule. We'll say 70 and 92. Okay, and so we want this area right here. And so we actually have to do the same thing we've done in the last two slides. We have to do it twice now. So the first thing we're going to do is we are going to find a z-score for 70 and 92. So we'll start with the 92. 92, take away my mean of 85, divide by my standard deviation of 10, is going to be 0.7. And then on the smaller value, 70 minus 85, divide by 10, is going to be negative 1.5. Again, values above the mean, greater than the mean, are going to have a positive z-score. Values below the mean have a negative. So now we've got the probability that z is stuck between negative 1.5 and 0.7. Before we had what is the probability that x was stuck in between 70 and 92. But now we're in the world of z's. And so what we're going to do is we are going to look up the following. We are going to area to the left of 0.7 and then area to the left of negative 1.5. So if we use our z-score table, area to the left of 0.7 is 0.7580. Area to the left of negative 1.5 is 0.0668. If we want area in between, we are going to take those two values and subtract them. That will give us a final score, or final answer, sorry, of 0.6912. Or to answer the question that was asked originally, what is the probability that a random score falls between 70 and 92 would be 69.12 or 69.12%.